Alright guys, let's take a look back at that force and acceleration lab going with the carts, because I think a lot of people might not have known what was going on. So we're trying to figure out, how does force affect acceleration? How does force affect acceleration? We got two variables here. This is going to be our independent variable. This is going to be what we change. Remember, an independent variable, that's what you change. And we're going to change that each trial. So maybe in trial 1, in trial 1 we have a 2 Newton force. And then trial 2, we're going to switch it up. We're going to try 4 Newton force. And each trial we're going to measure the acceleration. What is the 2 Newton force? How does that affect acceleration? We're going to switch up the forces. 4 Newton force, how does that affect acceleration? Try a 6 Newton force out. How does that affect acceleration? That's our independent variable. That's what we change each trial. Our dependent variable, this is what we measure. We're going to measure the acceleration. What we measure. And we're going to measure it using the slope of a velocity versus time graph. We'll go into that later. Now the constant, this was tricky. The constant is the mass of the system. We might be moving some masses around, but the whole mass of the system, that's going to stay the same. That's our constant. So what was the experiment? Well, the experiment, what we did was we had a cart. We had a cart with some wheels on it, and it was sitting on a table, and the cart was attached to a string. I put a little loop on the end of the string there, and there were some masses on the cart. Maybe some were the same size, maybe there was a different size one. And we had a motion sensor set up too. That was how we were going to measure our acceleration. Now, as is, this thing's not going to accelerate at all. All the forces on this thing are balanced. But what if we took a mass, let's use a different color here, and we moved it. We moved it over here. We moved it to the end of the string. Well, now what you got? You have the force due to gravity now pointing down in the downward direction, and there's no normal force, nothing balancing that out. This system, this whole system here, it's going to start to accelerate. It's going to move, and we're going to measure that. And maybe we measure it. It's going to be, I don't know, 0.1 meters per second. That's the acceleration that we got. And you're, oh, cool. Now we're gonna add more mass. Let's add another mass. So use this color again. Switch the masses up, and I'm gonna put it, over here. Maybe we double up on the string here. Maybe that's what you did. And now we have a much bigger force here. It's twice as big. We just doubled the mass here. So the force due to gravity, this unbalanced force, this is a lot bigger. Now we have a 4 Newton force. Now we're going to measure the acceleration. Maybe you get 0.2 meters per second. And that's the acceleration that you get. But notice that this whole time we're always keeping these same masses, and the whole mass of the system, that stayed constant. Now maybe you had a smaller mass, or I don't know, you try this last one out. That's off the cart now. That's hanging out down here. Now you have it's pretty heavy down here. You have a huge force due to gravity pointing in the downward direction now. This is now my free body diagram. It's way big now. This is a big arrow. This is a lot of force. And we get a big acceleration. The acceleration now is, it's 0.3 meters per second. This thing's really starting to increase the change of velocity. The velocity is changing at a faster rate now. Now this last one here, maybe you took all these off, and maybe you tried doing this. Here, I'll draw another little cart if I have enough time in this video. Yeah, maybe a couple more seconds here. Maybe you put all those three back on there, and you tried that little one there. You put the little one on this guy, and you measured the acceleration with the motion sensor. And maybe that this force right here, that was a really tiny force. That was just 1 Newton. That was just a 1 Newton force right there. And we figured out, oh man, maybe that was only, I don't know, 0.05 meters per second. So anyways, this whole time, we've always kept the mass of the whole system constant. We've changed the force. We've changed the force, and we measured the acceleration. That was the basic gist of this lab. And maybe I'll ask you some questions about what you just saw in this video.